This is section 3.4, page 3. We're going to add acceleration to the mix now. Let's recall S was the function for position or distance, either way. Velocity is S prime, the derivative of position, and specifically we'll call it instantaneous velocity. And think of instantaneous velocity as the rate of change of distance. And then now acceleration. Acceleration, if you think about it, is just the rate of change of velocity. So it's going to be v prime. That's the rate of change of velocity. Or you could think of it as s double prime. And we're going to call it instantaneous. Spelled it wrong. Instantaneous acceleration. So acceleration at one instant in time. And it is the rate of change of velocity. Okay, so acceleration is going to tell us about velocity. So in the case where we have zero acceleration, you can just think of that in your car. If you have zero acceleration, you have a constant velocity. And if acceleration is positive, so acceleration is greater than 0, then your velocity is increasing. So if you're stepping on the gas, your velocity is increasing. And if the acceleration is negative, velocity is decreasing. So that'd be like stepping on the brake. Okay? So acceleration, the derivative of velocity, rate of change of velocity, and it's the second derivative of position. So let's take a look at that problem we've been working with all along here. We want to determine where that particle has increasing or decreasing velocity. The function, again, the position function was s equals t cubed minus 6t squared plus 9t minus 12. So to determine whether we have increasing or decreasing velocity, we're considering the rate of change of velocity, whether it's a positive rate of change or a negative rate of change, so we need to look at acceleration. So we're starting with the position function. We're going to need to get all the way to the acceleration function. So velocity is s prime, so that gives us 3t squared minus 12t plus 9. Acceleration equals velocity prime, or s double prime, 6t minus 12. Further you go, the fewer variables, or fewer terms we have, so it gets a little bit easier. Well, to determine where we have increasing or decreasing velocity, in order to get from an increasing to a decreasing velocity, you have to go through 0. So again, we're going to do some sign analysis work. So if I need to find out where we have a positive or negative rate of change of velocity, I can set this equal to 0 to find out where it changes from increasing to decreasing. So if we factor out a 6, we get a t minus 2 equals 0. So t equals 2 using the zero product property. So at t equals 2 is where acceleration is 0. And of course that means velocity is constant. That only tells us part of the story. I want to know, before it gets to time equals 2, what's happening. After time equals 2, what is happening. So we'll do a sign analysis. So on my sign analysis, I like to put a little a there to show that I'm working with acceleration. Time equals 2. I'm going to choose a value less than 2. So how about t equals 0? And I'm plugging it into this equation right here. Your fully factored equation is where you want to look. So the 6 is positive. 0 minus 2 would be negative. Overall, that's negative. And a negative acceleration, we go back up here, tells us velocity is decreasing. Just note that. For time equals, let's choose 3. We get the 6 in front is positive. Plug in a 3 there. The binomial is positive. Overall, that's positive. Velocity for a positive acceleration is increasing. Okay, so to answer the question, don't leave it up to your reader to interpret your sign analysis. Specifically write down your answer. So for time less than 2, velocity is decreasing. For time greater than 2, velocity is increasing. And we'll go ahead and say at time equal to, velocity is constant. So that's a full and complete answer. Okay, finally on this page we need to talk about the relationship, we need to talk about speed. And speed involves a relationship between velocity and acceleration. So in order to figure out if speed is increasing or decreasing, what we're going to do is consider the sign of the velocity function and the sign of the acceleration function. So I like to interpret each one of these individually. If velocity is greater than 0, that means the particle is moving to the right. If acceleration is greater than 0, it means velocity is increasing. And these are working together. Moving to the right, it's a positive direction. Velocity increasing, that's a positive effect. Both of those together result in speed that is increasing. If velocity is greater than 0, again, we're still moving right. But if acceleration is negative, that is velocity decreasing. So we have a positive movement to the right, but velocity decreasing kind of pulls against the positive velocity. They're working against each other. So what you actually have here is your speed is decreasing. If velocity is less than 0, we're moving left. Acceleration greater than 0, velocity is increasing. So we have moving to the left, a negative direction, and velocity increasing, a positive direction. Those are again working against one another. So the result there would be speed is decreasing. Finally, velocity negative means we're moving left. And if acceleration is negative, velocity is decreasing, which is another tendency toward the left. So these are working in unison, they're working together. So in that case, speed would be increasing. So the summary of this, if you take a look, the 2 times that speed is increasing is when the signs match up. The 2 times when the speed is decreasing is when the signs oppose one another. So to summarize, if velocity and acceleration have the same sign, then that means speed is increasing. If velocity and acceleration have opposite signs, then speed is decreasing.